Hello everyone, and you're watching AWS and Machine Learning, and the current topic for this lecture is data types and data transformations for machine learning. This is lecture number 21 given by myself, Shanaz Malik, and I'm a data scientist. Well, in this lecture, before we move any further, we need to understand, when we start EDA or perform any type of statistics on our data, it's important to get comfortable with the data types that are used, and there are only mainly, three data types. So those are, if in a broad sense we categorize our variables or data types, they are categorical variables, numeric variables, and text variables. And remember, different types of variables require different types of statistical and visualization approaches, and I will show you once we will be, doing some of our projects. So therefore, it is crucial that all of us understand how to classify the data you are working with. Okay, so let's move on. So here's the diagram, which simply shows you, you might have data types, numeric variables, you might have categorical variables, you might have text, okay, data. So these are the different types of data types, you might encounter while you are doing your machine learning projects. And from numeric, you might have continuous and discrete. I've given some examples. For example, continuous might be measurements taken at any value, that takes any value, and discrete are counts, integers. Whereas in categorical variables, we might have ordinal, obvious, there might be some order, and nominal, where there is no order in the categories. So this is just in the broad sense, just to classify our data types. So let's see what more we can learn. So category, let's take first, categorical variables, as it's very important to know how to handle categorical variables while you are in a machine learning project. Okay, it's very important. If we don't do it correctly, we might get not we might not be able to um, create an efficient model. Okay, now categorical variables are used to describe qualitative features about an observation, and then it describes categories or groups. And for example, we could ask a question: is this photograph of an animal or an human? Okay, so for example, if you see this photograph, we can ask, is this photograph an animal or a human? So if we say human, so we are we are just, you know category we are putting this in a category of humans. Okay, so for example, there might be another question, like Audi, BMW, and Mercedes are different brands, and we could also say they represent different categories, right? So a car might be in a category of Audi, or in a BMW or Mercedes. Please be careful. I'm not promoting any brand, but just an example. They're all good cars. And there are other brands, and you could put different cars in a different categories. Okay, so answers to yes and no questions, like if you are asked, do you own a car, the answer could be either yes or no. And you could ask, are you currently enrolled for data analytics professional lecture series? The answer could be, again, either yes or no. So now, if you see, for example, I have given you a small data set. Okay, we have two features here. One is day of week, which is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, days of the week. Okay, and there's one more target variable in this case, sales. Okay, feature. So here the days of week is a categorical feature as values fall or could fall in one of these categories, while as sales is a numeric data type, also in our case a target attribute. Okay, so it's understood. uh, for example, so this feature for us is a categorical feature. Okay, now let's move on. Let's now we need to understand that if we give this data, this categorical data into our machine learning, not all machine learning algorithms are good to handle categorical features. So what we could do before we send this data into a machine learning model, if into machine learning process, what we need to do, for example, we might encode our day of week feature and give Monday equal to 1, and assign a value of from if where there is Monday, we'll assign it to 1, and where there's Tuesday 2, and accordingly, up to Sunday equal to 3. And this what when we do such kind of transformation, and this is called as numerical encoding. Okay, numerical encoding. But remember, various machine learning libraries can't handle numeric and encoded features. We need to pay attention here as the number of unique entries increases. For example, you can see we have 7 different unique entries in the day of week at this feature. And if you see, every time we are giving a new numeric, integer, every time we have a separate category, so we have to give a new value. And if you see now, the number of unique entries increases. The categorical values, okay, the categorical values also proportionally increase. So the more the categories, and the categorical values proportionally increase as well, which is not good for which is not good for our machine learning process. Okay, this however is often not the best thing, as it creates an implicit hierarchy in the data, and in some sense assumes that the variable is ordinal. Okay, so this is the problem. Although there is no order between Monday, Tuesday, Wednesday, Thursday, and so on. They're all equal. They're just the categories. But our machine learning process and the model might behave. Might start assuming that a variable is ordinal, which means that this has kind of more priority than this, or this is more priority than this, and this. 5 is having more weight, or kind of more weight than the 4 or 3, and 7 is maybe the highest. But that's not the case in our example. Okay, now what happens, we have one more technique, which is called one hot encoding technique. Okay, where it's a process which converts categorical data into an integer representation that works better with classification and regression algorithms. Okay, to better understand what this means, I will illustrate it with an example which I have given, for example, here. And all possible categorical values of a feature, in our case day of week, are converted into separate columns. Okay, and the category to which sample belongs is shown as 1, while as absence is indicated by 0. So if you see, for example, in in here, for example, we had this was Monday. Okay, and we had a sales on Monday 50, it is mm, nearly half a million, right? 500,000 and 550,000 is here. Okay, so let's see what we did. So if you see the Monday, so we are showing the Monday as 1 because the first sale, this sale belongs to Monday, so we designate it with 1, and rest we keep as 0. So what has happened, if you see, the categories which was over this Monday, Tuesday, Wednesday, Thursday, okay, we will convert them into features, okay. If you see, okay, so Monday means, this is this could remain, as complete Monday, Tuesday. I'm just trying to save some space here. So Monday, so if you see, Monday sales is 1 and the rest are shown as 0, and the sales is the same. And here is the Tuesday sales, okay, so Tuesday sale is 1 and rest is showing that this sale doesn't belong to any other category, and here is the sales. So, but the disadvantage of doing so is that it increases the dimensionality of the features significantly. And just imagine, if you have many classes in the feature, if you have many categories, here we have only 7. Okay, so we could create these 1 2 3 4 5 6 7 features, right? But just imagine if you have a category of which has maybe 100 features or maybe 1,000 features, and then just think what will happen to this data. So this will increase the dimensionality of the features significantly, okay. As I said, if we have more class or more categories, so the sales data, thus, after one hot encoding, is represented as in the data table. So here, this is the sales data. After we have done one hot encoding on it, this represents the same thing uh, as is here, okay. This data uh, here, we converted it into this after one hot encoding. What you see, that what we have managed to do is, now we have all numeric data here, okay, and machine learning loves this. When we have numeric data, machine learning loves this, and it gives us better results. So this is just to, because I will be doing these, I will be using these techniques. If you if you be connected with me in future lectures, when we'll start doing projects, you'll see me doing these, implementing the various different techniques that are suited for the problem in hand at that point of time. But I'm just explaining all these data types and data transformations to you, so that once we will be doing projects, so you are comfortable and understanding what actually I'm doing at that point in time. Now the question time here is one hot encoding the best way to featureize the categorical data, or are there better ways to manage categorical data? It depends. The answer to this question is, it depends on the type of categorical data. Are the categories ordinal in some way? If so, you might be able to make them in a numeric scale. Then, do they refer to geographical data? Yeah, if yes, you might be able to convert them as distance from certain points, or relate as different from local and regional mode. You can try to cluster, it, and there are libraries like K-mods which will allow you to create clusters of categorical variables. Okay, just don't expect them to be as precise as numerical ones. Finally, if they have relatively few different values, you might just want to use a different machine learning approach. Any tree based classifier, which is, for example, decision tree, random forest, or boosting of any boosting of your choice, or a naive base, may give you further insights. All that, if you don't understand, or if the terminology, technical terms which I have used, are too much for all of you or some of you, please bear with me. I will do my best to clarify them in coming lectures. Now, what are the pros and cons of label encoding categorical features versus one hot encoding? The answer to this is, if the cardinality, which means the number of categories, if the cardinality of the categorical feature is low, relative to the amount of data that you have in hand, one hot encoding will work best. Okay, you can use it as input in any model. But if the cardinality is large and your data set is small, one hot encoding may not be feasible, and you have to remember that. And your model may not be able to learn as you would like it to learn. Okay, uh, an alternative is to try an approach like numeric or binary encoding and hope that your model can learn something useful from this, at a risk of overfitting. If you don't understand overfitting, I will be explaining all this in coming lectures. Okay, and or you can use a model like light GBM, which can directly handle categorical variables by using an alternative method for identifying variable splits. Okay, now let's come back to our data, because we have been using a bit of terminology which might be familiar with some of you, and some of might think what's happening. So if you know it, it's good, excellent. If you don't understand, if it's too much for you at this point of time, just please comment. I will do my best to explain them in coming lectures. Although I am going to explain everything, if I'm not explaining it now, I have to take. We are at the moment we are talking about data types and data transformations. Okay, for machine learns, and we will learn some here and some in future lectures. So stay tuned, stay connected. So let's come back to our data that was in our hand, and if you look at it, it appears to us that sales are high on the weekends. Okay, so if you see, for example, if you remember, it was Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So Saturday, oh, the sales is going up, and Sunday sales is also going up. So could we say that the sales on the weekend is high then? So you should always remember that the more you have data, but it should be a quality data, clean data, tidy data. The more you have it, up to a limit, it's always good and helpful to make better predictions. Okay, and understand our processes in a better way. So let's see. Now let's understand, what if there is another feature that's actually playing its positive role in sales too, and that feature is weather. We understand, we might have a day of week and it sales, okay, but maybe we have one more feature available for us, and which is weather. So when we had this sale, it was Monday, we had this sale, but the weather was cloudy. Okay, so Tuesday we had snow, for example, maybe in your place, in your area, we have snow as well. So what if this low sales is because it was a snowy day? Okay, not because it was just a working day. Maybe it was snowing, maybe heavy snow. We could have further, for example, one more feature which could classify, for example, cloudy, light cloudy, medium cloudy, or heavy cloudy. Okay, and same with snow, light snow, medium snow, and heavy snowfall, stuff like that. We could have more information, but at the moment, let's concentrate on this data. So basically, it is possible that combine this feature and this feature, combined, if you a combined feature, day of week and weather, might together actually be stimulating this sales. Okay, so remember, when we suspect that there is an interaction between features, we combine features to form a new feature. So whenever you suspect, and this is once we start doing, once we collect the data, we integrate the data, we connect to the data, we integrate it, we start seeing what features are available, and we start doing various kinds of EDA, exploratory data analysis, and we start understanding, and we have some expertise in the field, then these things you have to evaluate, and before you move into creating models and testing models and evaluating models and finally deploying models. But before we do that, we have to first, the data is important, the tidy data is important. You have to select the best features, you have to create the best features, you have to do some feature engineering. Now here it is, once as I said, I repeat, when we suspect that there is an interaction between features, we can combine, there's a possibility we can combine feature to form a new feature or new features. Okay, so let's move on. So now here I can combine this Monday underscore cloudy, and I can have that new feature. So new feature will be this underscore this underscore this. So Wednesday underscore snow, Thursday underscore snow, Friday underscore rain. And once we have that feature, so here is day of, or we might call it a new feature. It doesn't matter, it's as long as what suits you. So here I have combined two feature. So now it's day of week, and it has I combined it with the weather feature. So this can be day of week underscore weather, or it depends on how you would like to call it. That's not important. The important thing is you're combining now two features, and the sales is same. So combining feature is helpful when performing exploratory data analysis and feature engineering. Okay, now this is already a feature engineering. You have created from two separate features, you have created a new feature, and now uh, so so when we suspect a non-linear, let's come back. Combining feature is helpful while performing exploratory data analysis and feature engineering. When we suspect a non-linear relationship between the features and the target, the new features could create a meaningful signals for our model, and this process is known as Cartesian's transformation. Okay. Now, hope you understand it. If you don't, just send me comments, and I will do my best to explain it again. Now, summary until now is that with categorical variables, we must convert values into numeric, or where required, perform one hot encoding. I have shown you what is one hot encoding. Remember, there are other techniques which we shall discuss in future lectures or in projects. So stay tuned with me, stay connected. Now, we were talking about different types of variables that we might encounter, and one such is text. Okay, if you have text data, so what to do with it? As you know, machine learning algorithm doesn't understand text, but how we can process and use text data. So text data requires spatial data management. And for example, you have a have a data set of a movie data set. So you have one feature which is name of the movies, and you have another feature which is uh, genre of the movie. And what if, for example, you have to, for based on the name of the movie, you have to predict which genre it belongs to. You might have such a task in hand, or any other task. So how to, for example, handle, how we could handle such of data, such feature. Now, text data requires spatial data management. I have already said so. So let's assume we have a task in hand that we need to predict genre from a movie name. To achieve this, we need to convert text data, in our case movie names, into numeric features. Let's see how to achieve it. One such method is called bag of words representation. Okay, so first movie name text is first the movie name, which is in case is tokenized. What is now tokenization? Is an act of breaking up a sequence of strings into pieces such as words, keywords, phrases, symbols, and other elements called tokens. Okay, tokens can be individual words, phrases, or even whole sentences. in the process of tokenization, some characters like punctuation marks are discarded. The tokens become the input for another process like parsing and text mining. So in our case, each word becomes new feature, and feature of occurrence becomes its value, shown in next table. So let's see. So if you remember, so let's see, we had here it is a Braveheart and $1 Million Baby. These are names of the films, and so once we uh, do the trust, so if you see, Braveheart has now become a feature. $1 Million Baby, this was what name of the movie, but we have split it at as at a white space, and then we have created a new feature of each. So Notting Hill, Anil, Pretty Woman has now, pretty is separate, woman is separate, and you understand what I mean. And now, for example, we had this, if you remember, Braveheart drama. Genre was drama. Okay, now how we will represent it once we perform the tokenization. So here it is, Braveheart is 1 and rest is all 0. So we understand we are talking about Braveheart and its drama. And same goes with others. So $1 Million Baby. So 111. So this represents $1 Million Baby. Okay, and the rest is all zeros. Drama and so on. Okay, so by this transformation we converted text data into numeric features. Now if you see, we have all numeric features. This is our target variable, okay, which we are predicting. So when so we give we give these features to our model, okay, to predict what genre it belongs to. So by this transformation we converted a text data into numeric features. This could be now used by machine learning algorithms to predict the genre. Okay, so hope this if you don't understand anything, if something I'm missing, or I'm not explained enough, please do comment, and I will do my best to maybe make another video, or maybe reply to your comments as quickly as possible. Now, tokenization individual words may not always be enough for the required solution. Okay, if we have a problem and we need a particular solution, maybe a simple tokenization of individual words may not always be enough. So what to do under those circumstances? Now, as you know, now for example, okay, let's see an example. So you have a text. For example, you have text one is a data science subject is an excellent choice, not disappointed. So for example, so one of you, maybe one of you is saying, giving this statement, the data science subject is an excellent choice. So you are happy and you're not disappointed. Okay, and somebody else is saying data science subject is not an excellent choice. Maybe person is having difficulty in stats, or you need a strong hold of stats in data science, and you need a strong you need to be creative, you need to be hardworking, you need to have passion for data, to solve the complex problems, to create simple solutions. It's not always to create a difficult solution. Sometimes simple solutions can do the job. You have to manage the projects. So you need to have a number of qualities to actually become a data scientist. So maybe some of you, or one of you, is not happy with is not happy with these subjects, not comfortable with these subjects, and he might say, or he or she might say, data science subject is not an excellent choice. Disappointed. So if you see in these two texts, these two statements, uh, if I'm going to tokenize it, for example, this is same, okay. Then here is not, and if this not is here, okay, and this is same, okay. So this not here, if I take this not from here and put it here, so basically tokenization, after tokenization at white spaces, if you see, we get this data science subject is not an excellent choice. Okay, disappointed. We get exact same set of so we get exact set of bag of words from both texts, and please not so so sorry, this is please note. So this is not. Please note the meaning is different. Okay, it's not. It's please note the meaning is different. The meaning for both texts is different. I repeat, the please note the meaning is different. Okay, how could we capture the difference in text one and text two? Okay, there must be some solution, and the solution is n-gram transformation. So what is this now? N-gram transformation is a good question, okay, to be asked. Let's quickly check. Our lecture is going too long, so we need to complete it quickly. So the n-gram transformation takes a text variable as input and produce strings corresponding to sliding a window of n words, generating output in the process. For example, consider the text string, I really enjoyed reading this book. So specifying the n-gram transformation with window size 1 simply gives you all the individual words in that string. So if you go n-gram transformation of this string with window size 1, what you get, I really enjoy reading this book. Okay, so that's your n-gram transformation with window size 1, and so on. If you are going to now specify window size 2, what will give gives all the two words combination as well as the one word combination. Okay, specifying n-gram transformation with window size 2 gives you all the two word combination as well as the one word combination. So here, if you see, I really enjoyed reading this book. I really enjoyed reading this book. So this is the word combinations you get. These are the set of words combination you get when if you are giving window size 2 and so on. If you give window size 3, so what will happen? Now it will take three words together. I really enjoyed, and then really enjoyed reading, so on. And I hope it makes sense to you now. Now, please note, we can request n-gram with the size ranging from 2 to 10 words. N-gram with size 1 are generated implicitly for all inputs, okay, whose type is marked as text in the data schema, so you do not have to ask for them. Finally, keep in mind that n-grams are generated by breaking the input data on white space characters. What does that mean? For example, punctuation characters will be considered a part of the word tokens. Okay, generating n-grams with a window of 2 for a string. For example, if you have a string red comma green comma blue, will yield red comma, so this comma will be added to this, and green comma will be added to this, and blue. Okay, so if you see red green blue and then red comma green green comma blue, and you know what I'm now talking about. So you can use the punctuation remover processor described later, or we will be doing all this. I will show you how we do it, how we use libraries available to us to do all this stuff to remove the punctuation symbols if this is not what you want. For example, maybe you don't need these commas in your solution. So I will show you how to remove it when we do later on, maybe projects or some in-depth lectures. Okay, moving on. I hope you understand now. To complete an n-gram of window size 3, for example, for a variable v1, all you have to give, you have to first import these libraries, and you have to say n-gram variable 1 comma 3, and this means that you are actually performing window size 3 n-gram on this variable, and this variable can be anything. And in our case, for example, it was, for example, I really where is that? Here, for example, it was, in our case, this is our variable 1, for example, or it can be any variable. It depends from project to project. Okay, now why n-gram transformation is important? So n-gram transformation, window size 2, this will give us two words combination from our text in hand. For example, we have two texts as below. Okay, this much I have explained you. I don't need to explain it again. I had a colleague who asked me this question again and again, so I had to make a separate slide for him. So I'm just adding this slide here as well. For example, you might have a I think I explained this. You might have a text. You might have a variable one, which is data science subject is an excellent choice, not disappointed, and someone else is saying data science subject is not an excellent choice, disappointed. So they are two different statements, different meanings. So text one gives us the following, with the window size 2. So if you see, you get data science, science subject, and so on. And here you get not disappointed. So this is clearly giving some meaning. And here choice disappointed, okay, is not. So if you see, you when you use this n-gram transformation with different window sizes, you start capturing it was not disappointed, or or a person was disappointed with the choice. Okay, so this kind of gives us, you do your text analysis using n-gram transformation methods. Okay, so please note, we get unique combination of words. Now machine learning algorithm uses these combinations to predict the outcome. There are other transformations, and let's get to know them first. I think this lecture is going too far. Let me give you quickly a small bonus, and before we close this lecture and we discuss everything else in coming lectures. So for example, if you see these transformations, text string analysis transformation techniques, n-gram, we have just now discussed orthogonal sparse bigram transformation, lowercase transformation, remove punctuation transformation, quantile binning transformation, normalization transformation, and Cartesian product transformation. More explanation on all of them in coming lectures, so stay connected. So as this lecture has gone too long now, so it's time to say please subscribe if you haven't until now, and please hit the notification bell so that you get notified as soon as I upload no new videos. I hope to see all of you in new coming videos. Until then, thank you all for watching Data Analytics Professionals. Yeah, remember, sharing is caring. Time to say goodbye.